Hello everybody, good to see you all again. Well, guess what? I can't see you, but you can see me. So here we are. Instructions have to continue. And so I have a few announcements for you. Let me begin by saying I hope you guys are safe. Everybody's taking precautions with your hand sanitizer and washing your hands. Keep your hands washed. Social distancing. Stay home. Do not leave your home. I'm in my home, and yes, I have a whiteboard here, and so instructions shall continue, but I'm hoping everyone truly stays safe, and that your families are safe, and that you are all right, that you're okay. We're going to continue our lessons by way of YouTube, so the rest of the semester, I'm going to post lessons. I'm not going to post them daily, but I may post them in chunks. Like tonight, I'm doing lesson 4.7, 4.8, and then tomorrow I may come back and do 5.1, 5.2. Then the next day I may do 6.1, 6.2. I'm gonna do them like that, so you can go and watch them whenever you feel like watching them. You can pause, you can fast forward, you can watch it again. If you have any questions about something that I say or something that I explain, teach, you don't understand it, you can text me, you can email me, you can just send me a message any way you know how, any way you can, and I'll try to accommodate you and answer it as swiftly as I possibly can. Okay? Test 3 is April the 6th, so test 3 will continue. It will be April 6th. I sent everyone the PDF regarding how to install the lockdown browser. You're going to need to have that installed in order to take test number 3. Okay? I think that's it by way of announcements. Again, if you have any questions, please be sure to text me. You can email me. You can take a picture of the problem and text that to me however you see fit. You can call me however you see fit, and I'll try to help you out as much as I can. All right? Okay, with that being said, let's get started. All right, so tonight, section 4.7. Here we go. All right. 4.7, which is special factorization. Special factorization 4.7. So first you want to start off, let's look at the perfect. Squares and cubes. Perfect squares and cubes. Here we go. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. Okay, these perfect squares, you should have an idea of what they are, and you should know them by memory, by heart. You should know them. That should not be a problem. These right here, okay? In like manner, you should know, in terms of variables, you should know that n squared, for example, that's n times n. Okay? N to the 4th That is n squared times n squared. N to the sixth. This is n to the third, or cubed rather, times n cubed. And so on and so forth. N to the eighth is n to the fourth times n to the fourth, so on and so on and so on and so on, so forth. Okay? Alright, so these are squares. Let's talk about the cubes. Let's get the cubes. You should be familiar with perfect cubes. Okay, here we go. The cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. It's a 1 with 3 zeros. 1,000. Okay, so when we talk about special factorization, we have to understand and know what the perfect squares are, what perfect cubes look like. There you go. This is going to open up the door for what we're about to do right now. Alright, so the first type of special factorization is 1, or 2 rather, here we go. Factoring the difference between 2 squares. Factoring the difference between 2 squares. Okay? Here we go. If, is point number 1. If a binomial can be written as, here we go, a squared minus b squared, then it can be factored. It can be factored as a plus b times a minus b, or a minus b times a plus b. Either way, one way or the other, either like this or like that. It can be factored either way. A plus b, that quantity, times a minus b's quantity, or a minus b quantity times a plus b quantity. It can be factored either way. All right, let's take a look at a few examples here. Here we go. So, example 1. Okay. So for our first example, let's say if we have 4x squared minus y squared. 4x squared minus y squared. Please notice, all right, that we have the difference between 2 squares right here. Difference, the word difference means minus. And if you notice, we have the minus sign here. Between This means in the middle. So we have a minus sign in the middle. So we have the difference between. The difference between 2 indicates we have 2 variables or 2 terms here. Term 1, term 2. So we have a minus sign in the middle of 2 squares, and both of these are squared. There's 4x squared and the y squared, so they're both squares. So this is definitely the difference between 2 squares. Okay? All right, now let's consider how we're going to factor this. All right, here's how we're going to factor it. All right, here we go. So you take this 4x squared, right? And you go back here and look at what 4 is. Look at 4, for example. 4 is 2 squared. 4 is 2 2's, right? And x squared, which is like saying n squared, is n times n. So you want to write 4x squared as 2x times 2x. Because that's what 4x squared is. It's 2x times 2x. And y squared is y times y. Okay, that's going to do it. If you can get to this one step right here, you're going to be good to go. Watch this. Here's why. Here's why that's awesome. Here's why. Once you write this, go ahead and write the shell. The shell is this right here. Parenthesis, parenthesis. And it doesn't matter. You can put the plus first and then the minus, or you can put the minus first and then the plus. It doesn't matter. It does not matter. So the plus, I'm going to bring the plus down here, and the minus, I'm going to bring the minus down there. And once you do that, you're good to go. Watch this. You see this 2x? I'm going to place this 2x right here. You see this y? I'm going to place this y right here. So I'm combining these two. I combine those two. Okay? Now notice I have another 2x and y remaining. No problem. So now I'm going to combine this 2x with this y right here. Put those two together. Right there. 2x minus y. I'm done. That's it. That's how you factor the difference between 2 squares. So 4x squared minus y squared equals 2x plus y quantity times 2x minus y quantity. That's a wrap. That's all you have to do. Let's look at another example. Example 2. Example 2, let's see. Now let's take a look at, okay, 25 x to the 4th minus 9. First, recognize you have the difference between 2 squares, because 25x to the 4th, that's a perfect square. How do you know that? Because 25 is here, and I have an n to the 4th right there. They're perfect squares, and so is 9. How do I know that? Because I have a 9 right here. Okay? So they're perfect squares. And notice this, there is no greatest common factor between these two terms other than 1. And we're going to get to some examples that contain a greatest common factor, or what we call the greatest monomial factor. We'll get to examples like that. But there's no greatest common factor here. Let's go ahead and break each one down. Break this one down. All right? So 25x to the 4th, how can I rewrite it? I can write it as 5 x squared times 5x squared. Got it. Done. How about 9? How can I rewrite 9? You see it right here. 9 is 3 times 3. Okay, there you go. Now try to do what we did right here. You do it. Write the shell first. The shell says that this is going to equal, here we go, boom, boom, boom. We can make it a minus and make it a plus. It doesn't matter which one comes first, plus or minus, doesn't matter. All right, once we do that, okay, just go ahead and put this 5x squared with this 3. So I'm going to go 5x squared and 3. And then put this 5x squared with this 3. 5x squared and 3. And congratulations. That's our answer. Done. You got it? We good? Let's do a couple more. All right. Example number 3. Okay. Example 3. Let's say we have 36a squared minus 49b to the, whoops, not 6. I want to make that b. b to the power of 6. b to the power of 6. Well, is the greatest common factor between 39a to the a squared and 49b to the 6 other than 1? No, there is not. So now let's go ahead and see how we can go ahead and factor each term. Let's factor each term here. So 36a squared, how would you break that down? Well, that's going to be 6a times 6a. 49b to the 6, that's going to be 7b cubed times 7b cubed. And now there you go. It's easy now. So you do to this what we've been doing with the other ones. Okay? So this is going to give me, do the shell first. Make this plus, make it minus. Now put 6a, this term with the 7b cubed. And then right here, put the 6a there. And then this 7b cubed right here. And there you go. It's factored. We're all done with that. Any questions? Like I can really hear you. Any questions? I can't hear you. Okay. If you have any questions, email, send a text. You got it? All right. One more example, then we want to move on. One more. I think I have too many markers up here. All right. Example 4. Example 4, let's look at 5 minus 45x squared. This one's interesting. Can you tell me why? Why is that one interesting? What do you notice? Oh, and by the way, I can't hear you. What do you notice here? You should notice, ladies and gentlemen, that between these two expressions, these two terms, the greatest common factor is a 5. So you can factor out of 5. Do that first. In this case, the greatest common factor is not 1, but it's 5. So factor out the 5. All right, let's do that. So I'm going to factor out 5. And I'm going to be left with 1 minus 9x squared when I factor out the 5. Here's what I suggest you do. Here's my suggestion. This 5 right here, put that in your back pocket. Put that 5 in your back pocket, but do not forget it's in your back pocket, because you have to take it out and paste it on the answer at the end. Okay? So put that 5 in your back pocket. And once that's done, 5 in the back pocket, look at what you have remaining. You have 1 minus 9x squared. So that has to be factored. That has to be factored. So let's factor that. So we have 1 minus 9x squared. Alright? So this 1 is going to give me 1 times 1. And 9x squared is going to be 3x times 3x. And now do the shell. Make 1 plus, make 1 minus. Put this 1 with this 3x. 1 plus 3x. And then put this 1 with 3x right here. 1 minus 3x. Okay, there you go. Is that the answer? We got it? We're finished? We good? What's wrong? Oh, the back pocket. That's right. That's right. Some of you guys got it. Good job. That's not the answer. If you forget this 5, you're wrong. This 5 has to be a part of the answer. So this is not the answer. No, no. The answer is 5. Take it out your back pocket. Now bring this back. Times 1 plus 3x. Times 1 minus 3x. That's the answer. Okay. All right, now we're good. Very good. Any questions about the difference between two squares? We good? We're going to move on now. All right. We're going to move on. Okay. So that's number 2, factoring the difference between two squares. So let's get rid of all of this. Factoring the difference between two squares. That has to go now. Goodbye. See you later. Come off the board. We have factored the difference between two squares. Alright, so that's over. So now let's take a look at number 3. Now let's look at factoring perfect trinomial squares. Factoring perfect trinomial squares. Let's take a look at that. All right. If a trinomial can be written in the form, all right, here it is. If it can be written in the form a squared plus 2ab plus b squared, okay, or a squared minus 2ab plus b squared, then it can be factored as, here we go, A plus B quantity squared, or A minus B quantity squared. There you go. Okay? Now these are perfect trinomial squares. Alright? Well, what makes them perfect? What makes it a trinomial square? Well, trinomial, well, that means a polynomial of 3 terms. Right? 3 terms. We have 3 terms. 1, 2, 3. 1, 2, 3. Well, what makes it a perfect square? Well, what brings this word perfect and square together? Alright? Well, that's because the first term is a perfect square and the last term is a perfect square. That's the key. The first term is perfect square and the last term is a perfect square. That makes it a perfect trinomial square. Because the first term is a perfect square and the last term is a perfect square. There you go. And if you keep your eye on that, if you notice that, you're going to be alright. Let's look at a few examples. Let's see if we can notice that. Well, let's see if we can identify the perfect squares here. Okay, example 1. Alright. Let's factor, here we go, 9 x to the 4th plus 24 x squared y squared plus 16 y to the 4th. Now, whenever you factor anything, you always first check to see if there's a greatest common factor other than 1. In this case, we have a 9, 24, and 16. There is no common factor that can be extracted from these expressions other than 1. Well, at least that's an integer anyway, other than 1. So there is no greatest common factor, so we have to look to factor this. And we've already discussed other types of factoring, but in this case, this one is what? A special type of factoring, because look at the first term and look at the last term. And ask yourself, is the first term and the last term a perfect square? Let's see. Let's see. Okay? If this eraser falls again, I think I might put it in my pocket. I better yet leave it on the ledge. How about that? Alright. How about 9x to the 4th? Is that a perfect square? It's still on the board over here. Can you break it down? Is it perfect? Let me see what I can do with this one. I can write this as 3x squared. Yes, that is a perfect square. That's 3x squared times 3x squared alright, which is 3x squared to the power of 2 squared. Got it. How about 16y to the 4th? That is 4y squared times 4y squared, which is going to be 4y squared, and there are 2 of them. See, 1, 2. Just like the 2 of these. See, 1, 2. 2 of them. That's it. They're perfect squares. So all you do is you take what's in the middle, 3x squared. So my answer is going to be 3x squared plus and you take this term, what's in the middle? 4y squared. 4y squared and square it. That's this square right here is where this outside square comes into play. The outside square takes it there, and what's inside goes inside. And that's going to give me the answer. And that's it. That's how you factor it. Okay? Because if I were to multiply 3x squared plus 4y squared times itself, it gives me this answer right back. Okay? In other words, if I were to take 3x squared plus 4y squared, if I were to square it, this means write it 2 times. Write this twice. Once, twice. Now, if I multiply this thing together, my answer is going to be that. That's the point. If I multiply it, I'm right back where I started. Let's see. What is 3x squared times 3x squared? That's going to give me 9x to the 4th. And then take 3x squared times 4y squared. That's going to give me plus 12x squared y squared. And now let's multiply 4y squared times 3x squared. That's going to give me plus 12x squared y squared. And lastly, take 4y squared times 4y squared. And that's going to give me plus 16y to the 4th. And now what we have to do is add up the terms in the center. Add those up. And we're going to be left with 9x to the 4th plus 24, because 12 plus 12 is 24. X squared y squared plus 16y to the 4th. Check, check, check. There you go. So this expression can be factored to this expression here. And you can check this by multiplying. You're not going to be asked to check it. You're going to be asked to factor it. But you can always go back and check it by doing this process right here. Okay? All right. Everybody good? Just breathe, breathe. Listen, if you have to, you can pause the video, come back to it. It's up to you. Watch it tomorrow morning. Watch it this afternoon. Watch it tomorrow night. You're in control. Not me. You. Okay? All right. Let's look at another example here. I'm going to erase this now because we're into it now. I'm going to let this go. I'm going to let this go. Okay. Here we go. How about this one? Example 2. 25 y squared minus 30xy plus 9x squared. Greatest common factor between 25, 30, and 9 other than 1? And the answer is correct. No. There's no other integer that's the greatest common factor other than 1. So that's out. All right, look at the first term and the last term. Is this a perfect square? Is this a perfect square? This time, let's go straight to the root of the situation. Let's go straight to the root of the perfect square. The root of this perfect square is 5y. And This is the root. And the root of this perfect square is 3x. Congratulations. You're done. That's a wrap. Nothing left to do. But watch this. The only thing left to do is this. You see this minus sign? Bring the minus sign down. Put it here. Put parentheses around it. And square it. It's factored. That's the end of it. That's the answer. So if you want to factor 25y squared minus 30xy plus 9x squared, it factors into the quantity of 5y minus 3x quantity squared. That's the answer. That's it. And you can verify this by going back and multiplying it. Oh, watch this. Look. Look. 5y minus 3x quantity squared, right? All you have to do to verify it, I'm going to call this the check. How do you check your work? Take this term and square it. 5y squared. And then go minus, and then go this term times that term. 5y times 3x times 2. 5y times 3x times 2. And then go plus the last term squared. 3x squared. The reason I put a plus right here is because when I take this last term, 3x, and square it, my answer is going to be positive. Okay? In other words, negative 3x squared is the same thing as plus 3x squared. Which one do you want to write? This one right here gives you 9x squared. That's positive. And this one right here also gives you 9x squared. That's positive. You can write it either way. Okay? Alright, so there we go. So this is going to give me 25 y squared minus 5 times 3 is 15 times 2 is 30 minus 30 xy plus 9x squared. There you go. So that's the check. So it all works out. It's verifiable. Okay? Let's do one more example like this. Let's do one more. Example 3. All right. Example 3. Here we go. 16 minus 24x plus 9x squared. Okay? So, well, you know what? Tell you what, let's do this. Let's go a step further. Let's make it 32 minus 48x plus 18x squared. Let's do that. Let's factor that. First thing you do is check to see if you have any perfect squares up here. Is the first term perfect square, the last term perfect square? The answer is no. Oh, wait a minute. Wait. One thing we did not do. We did not check to see if there's greatest common factor. Is there something we can factor out of each term? Let's check that out. Let's see if there's something we can factor out. What's the greatest common factor? The greatest monomial factor that each term have in common. Do you see it? Yeah, I think someone sees it. You can factor out of 2 from each term. Factor out of 2. Okay? So let's factor out of 2. When we say factor out of 2, it means divide each term by 2, okay? So if I divide each term by 2, 2, 2, 2, the 2 goes out in the front yard, 2. All right, and it's going to be 32 divided by 2 is 16, minus 24x, plus 9x squared, if we factor out 2. Now, once the 2 is factored, right, you take that 2 and you place it in your back pocket, and don't forget it's there. That's critical. So this 2, right, this 2 right here, again, that goes into the back pocket. And don't forget it's there now. That's easy to do. All right. Which means if the 2 is in the back pocket, we're now going to work on 16 minus 24x plus 9. Let's just work on this. All right. Is 16 a perfect square? Yes. How about 9x squared? Is that a perfect square? Perfect? Yes. So let's go ahead now and factor it and break it down. Let's factor it, okay? Oh, and by the way, one other thing you may also want to do when you're factoring these, right? You may want to take the expression and you might want to turn it around, and you might want to put the x squared, the 9x squared, write that first. Write it first. So let's rewrite this. Watch this. Let's write this as 2 times positive 9x squared, 9x squared minus 24x plus 16. So why did we take it and turn it around like that? Because it factors a little easier. You may be able to recognize it if it's in what? Standard form. That's standard form. So now we're in standard form. This 2 is still where? In our back pocket. So now let's go back and work on this 9x squared. And let's work on the 16. And let's get to the root of this. And let's get to the root of this. Okay? The root of 9x squared is 3x. The root of 16 is 4. This minus sign, bring it straight down. And don't forget, parentheses and square it. And there you go. So my answer is going to be 3x minus 4 squared. Okay, good job. Good job. Got the answer? What? I did what? Oh, you're right. I forgot the back pocket, didn't I? Please don't forget the 2 in the back pocket. Go back and grab it. So it's going to be 2 times 3x minus 4, quantity squared, and that is my answer. That's going to give it to me. Very good. Any questions so far? All right, so first we looked at perfect squares, perfect cubes. Then we went into factoring the difference between, in the middle of 2 squares. Now we have looked at factoring perfect trinomial squares. And so there's one other thing that we have to look at. There's one other topic in this section here that I want to go into. One other one. And this one is called number 4. Factoring. Sums and differences of cubes. Factoring sums and differences of cubes. So here we go. If a binomial can be written in the form x cubed plus y cubed or x cubed minus y cubed, then it can be factored as x plus y times x squared minus xy plus y squared, or x minus y times x squared plus xy plus y squared. Okay? Let me just write it like this. Here we go. X cubed plus y cubed equals this one right here. X plus y times x squared minus xy plus y squared. Okay? In like manner, x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. There you go. Here are the rules. Right there. Okay, so that's what we're going to use to factor the difference. All right. Let's look at a few examples. Example 1. Example 1 under this heading. Let's say we have 8x cubed minus 27. We have to factor that. So the first thing you have to recognize or identify is it the difference between cubes, between squares? Is there a greatest common factor? Is it even factorable? There are a lot of things we have to look at. All right? So, is there a greatest common factor between 8 and 27? Other than 1? Answer is correct, no. All right? Question number 2. Is it the sum between two cubes or the difference between two cubes? Answer is this one. It's the difference between two cubes. So this is the difference between cubes. So if it's the difference between cubes, then I know that x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. All right? The most important step when you have these cubes, ladies and gentlemen, is this. Here's the key. If you do this, you're going to be okay. Don't miss this. You have to take 8x cubed and rewrite it. 8x cubed has to be rewritten as such. Parenthesis, parenthesis, cube out front, minus, parenthesis, parenthesis, cube out. See that? This is the shell now. This is the shell. Out, 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 out. Now, this 8x cubed has to be rewritten as 2x. Because if you take 2x and cube it, then you get 8x cubed. And then 27 has to be written as 3 cubed. Because that's what 27 is, 3 cubed. Alright, so now, these purple quantities here, 2x and 3, this becomes your x, and your y. So this 2x right here, you substitute it in for x. And this 3, you substitute it in for y. Everywhere. Wherever there's an x here, you want to put 2x. Wherever there's a y, you want to put 3. So then this is now going to become 2x minus 3 times 2x squared plus 2x times 3 plus 3 squared. And there you go. Please notice that wherever there was an x and a y, I substituted every x up here for 2x, and I substituted every y for 3 everywhere. Now let's simplify it down. So therefore, I can conclude that 8x cubed minus 27 equals 2x minus 3 times. Well, what is 2x quantity squared? 2x quantity squared, well, that's going to be 2x times 2x, which is 4x squared. 4x squared plus, well, what is 2 times 3? 6x. Plus, and what is 3 squared? 9. All right, there you go. That's the answer. It's factored. It's factored. This was the big step right here. Rewriting it in terms of 2x and 3. That's critical. You have to rewrite it in terms of 2x and 3. All right, let's take a look at another one. Let's do one more. Let's see here. Okay, here we go. Example 2. Let's look at 8x power 6 plus 1. No GCF other than 1. Is this the difference between cubes or the sum between cubes? Well, there's a plus sign, so evidently it's the sum. Between cubes. Okay? How are we going to rewrite it? Well, let me do the shell first. Here's the shell. Cubed plus cubed. There's the shell. What goes on the inside? In fact, let me give you some more room. We come down just a little bit lower with the shell. Cubed plus cubed. What goes on the inside? Well, how can I rewrite this to make it fit in my shell right here? Well, I know that 2 cubed is 8, so a 2 can go right here. All right, and then I know that this can also be x squared. X squared if you break it down. Okay? Just as we did over here, because 2x cubed, 2x squared to the power of 3 quantity cubed is 8x to the 6. So this is how you have to look at 8x to the 6th. You have to regard 8x to the 6th as 2x squared, and this whole quantity is cubed. Why? Because 2x squared times 2x squared times 2x squared equals 2 times 2 times 2 times x squared times x squared times x squared. Well, 2 times 2 times 2 is 8, and this is going to be x, and you add the exponents, add these numbers, add them up, 2, 4, 6. That's why. You see that? That's why. So in here goes 2x cubed. What about in here? What goes in there? Obviously it's what? Yep, 1. Obviously it's 1. All right? And so now, our 2x squared put all of that in for x, and 1, this goes in for y. And we know we have to use x plus y times x squared minus xy plus y squared. Put it in. So we're going to have 2x squared plus 1 times 2x squared squared minus 2x squared times 1 plus 1 squared, which is going to give us 2x squared plus 1 times 4x to the 4th minus 2x squared plus 1, and there's your answer. Which makes sense. Which makes sense because we do know that 2 plus 4 is 6. Now our highest power up here is 6. So that's going to give it to us when we factor it. Okay? All right, very good. Very good. All right, we got one more example, and that's going to do it for 4.7. All right, so now we're going to go, that's example number 2. Let's go into example number 3 now. Example 3. All right, in this example, what if we have 54x cubed plus 2. You know what, let's switch it up this time. Let's call it, let's use a different variable, a. 54a cubed plus 2. Now what do we do in this case? 54a cubed plus 2. What do you think we should do? Well, let's see here. Well, notice, if you will, we have a sum between two cubes. First, determine if there's a greatest common factor. What can you factor out? What can go? I have 54x cubed plus 2. Please notice that the greatest common factor, the greatest monomial factor, is the 2. So let's factor out a 2. So we're going to have 2 times 27a cubed plus 1. Here's what I suggest. I suggest you take this 2 and put it in your back pocket. Put that 2 in your back pocket. And work with 27a cubed plus 1. All right, let's do the shell now. Here's the shell. Boom, boom, plus boom, boom, cubed, cubed. All right. So how do we rewrite 27a cubed? How do you rewrite it? Well, you write it as 3a. Because 3a cubed is 27a cubed. How do you rewrite 1? Well, simply a 1. Okay? So what does this mean? This means that this 3a, that is x, and this 1 is y. So it's going to be x plus y times x squared minus xy plus y squared. And whenever there's an x and y, you substitute 3a for x and you substitute 1 for y. Plug it in. That's it. So here we go. So 27 a cubed plus 1 equals, let's go, 3a plus 1 times 3a quantity squared minus 3a times 1 plus 1 squared. Let's simplify it down. 3a plus 1 times 9a squared minus 3a plus 1, and there you go. That's your answer. Right? No. Don't forget what's in your back pocket. So, 54. A cubed plus 2 equals 5 times, no, not 5, it should be a 2. 2 times 3a plus 1 times 9a squared minus 3a plus 1. All right, there's our answer. Now we got it. Any questions about that? We good? So there you have it. That's section 4.7. That's everything in totality. All right? So we have just covered special factorization. If you have any questions, if you have any comments, please be sure and email me, and I'll answer you as soon as I possibly can. All right? Okay. Now let's transition directly into section 4.8. All right? And again, you can stop the video, take a break, whatever you need to do. But I'm going to keep on going. Now we're going into section 4.8. Here we go. 4.8. This is solving polynomial equations. Solving polynomial equations. Solving polynomial equations. All right. Okay, first, the process. Okay, the first thing you need to do is write the equation in standard form. ax squared plus bx plus c equals 0. That's step 1. Write it in standard form. Step 2. No, not if. Factor first. Factor. If possible. Step 3. Solve for the variable. That's it. Do those 3 things, and we'll be solving polynomial equations. Example 1. Solve for x. Okay, let's take a look at example number 1. Let's say if we have 10x squared plus 25x equals 0. Well, first things first, write the equation in standard form, meaning all the terms on one side and 0 on the other side. That's already in standard form, so step 1 is already a check. Step 2, factor if possible. So this side here has to be factored. Well, what are the greatest common factors of 10x squared plus 25x? I know I can take out a 5 and I can also take out an x. So extract the 5x, and I'm going to be left with 2x plus 5, and that equals 0. 2x plus 5 equals 0. Okay? And from this step, you must set each factor equal to 0. Here are the factors. There are 2 factors here. Here's one factor, 5x. And the other factor is 2x plus 5. So set each factor equal to 0. So we're going to have 5x equals 0, or 2x plus 5 equals 0. That's each factor equal to 0. Okay? Now solve each factor. Solve the first one, then solve the second one for x, and that's going to get it. Let's solve the first one. So 5x equals 0, divide both sides by 5. 5's cancel out, bring down the x, bring down the equal sign. 0 divided by 5 is 0. That's one answer, one solution. X equals 0, and let's solve the second one now for x. So we got 2x plus 5 equals 0. Subtract 5 from both sides. So you got 2x equals negative 5. Now divide both sides by 2. 2's cancel. Bring down the x. Bring down the equal sign. Negative 5 divided by 2. Okay? So that gives you both solutions right there. So here's how you write it. So in the end, x equals 0 or. Not and, it's or. X can't be both at the same time. X equals 0 or x equal negative 5/2. It's one or the other. It's one or the other. It can't be both. That's like saying, you know, Professor Wright is 30, you know, and Professor Wright is 50. Well, I can't be both. I can be one or the other, but I can't be both at the same time. Likewise with x. X can't be 0 and negative 5/2. X is one or the other, not both. Okay? All right. That's example 1. Example 2. Okay? Let's see what's next. Example number 2. 10x squared equals 13x plus 9. That's interesting. Step 1. Well, it must be written in standard form. It's not in standard form. Write it in standard form. So let's subtract 13x from both sides. That's going to give me 10x squared minus 13x equals 9. And then subtract 9 from both sides. I'm going to have 10x squared minus 13x minus 9 equals 0. All right, very good. So now I'm in standard form. That takes care of step 1. Write the equation in standard form. This is your standard form. Step 1 is a go. Step 2 says what? Factor if possible. Well, in my attempts to factor this, I noticed there is no greatest common factor here other than 1. That's the first thing I noticed. The second thing I noticed is that this term and these two terms, the first and last terms, are not perfect squares. So now I have to think about how I factored, right, in like section 4.4 and 4.5 and 4.3. How do we factor in those lessons? What was our approach to factoring? Okay, so here's what I'm going to do. Here's the quickest way, most convenient way to factor. All right. First, consider 10 times minus 9. 10 times a minus 9, that equals negative 90. I need two numbers that multiply to negative 90, and they add up to negative 13. Write my binomials. I'm going to put a 10x and a 10x. What are the two numbers? Well, let's see. What gives me 90? Well, of course we know, start with the multiple first. 90. What gives me a negative 90? Well, I know negative 10 times 9 is negative 90. I also know that a 5 times negative 2, that's also times 9. It's also going to be 90. All right. And how about that? There you go. Why don't we put these two together? Boom. Let's try that. Negative 2 times 9, that's 18. Let's try 18, negative 18 and 5. And let's see if that's going to work it out for us. After breaking it down like that. Let's see. Here is negative 18. Here is 5. That's negative 90. And negative 18 plus 5 is negative 13. So here I'm going to go minus 18. And here I'm going to go plus 5. You can solve it like this if you want and go straight to the answer. Or you can break it down like we did with factoring, factoring out the greatest common factor in each binomial and get rid of it. Okay? Let's do it that way first, and then we'll come back and just work on this right here. Okay? So I'm going to put an arrow over here to look at 10x minus 18 times 10x plus 5 equals 0. We'll come back and tackle that. But let's just break this down the way we did in section like 4.4, 4.5, 4.3 when we learn how to factor. Okay? The greatest common factor right here is going to be a 2. So take out a 2, and I'm going to have 5x minus 9. The greatest common factor here is a 5. Take out a 5. And I'm going to have 2x plus 1 equals 0. And of course, get rid of the 2 and get rid of the 5. And so if you want to factor this, it's going to give me 5x minus 9 times 2x plus 1 equals 0, and solve that. This means that 5x minus 9 equals 0, or 2x plus 1 is 0. All right, let's solve the first one. Let's look at 5x minus 9 equals 0. So 5x minus 9 equals 0, add 9 to both sides. We're going to get 5x equals 9, and then divide both sides by 5. So x equals 9/5. That's one answer. Now solve the other. 2x plus 1 is 0. Subtract 1 from both members. You get 2x equals negative 1. Divide by 2, which means x equals negative 1/2. And there you go. So those are my solutions. X equals 9/5 or x equals negative 1/2. Okay? Did I have to do all of this and find the greatest common factor in each binomial and get rid of it and solve it? No. When you're solving these polynomials, you can go ahead and just solve each factor from this stage right here. You don't have to reduce it as we did for factoring purposes. If I had said 10x minus 18 equals 0, or 10x plus 5 equals 0. If I solve this, I get the same answer. I get the same thing. Because here, if I add 18 to both sides, I'm going to get 10x equals 18, and then divide both sides by 10. And I get x equals 18 over 10 is 9/5. And that's what I have right here, 9/5. You get the same thing. Okay? And then over here, I'm going to get x equals negative 1/2. If you solve that out. All right? So x equals one or the other, not both. One or the other. Okay, that's example number 2. Example 3. All right. How about this one? 9x squared minus 48x equals negative 64. Solve that for x. All right. Solve this for x. Solve for x. First, step 1. Write the equation in standard form. That's the first thing. Thank you. I'm trying to teach you guys. I got my wife, my son, my daughter. They're all looking and going like this. Get away from here. Okay, negative 64 must come to the left because it has to be written in standard form. So we're going to have 9x squared minus 48x plus 64, and it equals 0. All right, factor it if possible. Now in this case, is there a greatest common factor monomial other than 1? No, right? Do I have to do the same thing I did over here? I could, but notice this. With this problem, 10x squared and, well, not there, here. 10x squared and 9, they were not perfect squares. 9 is perfect. X squared is perfect. Equipment falling apart. Okay. Great. Oh, how did this thing come off here? I'll tell you what. I'm going to set this off to the side and keep on going. Okay. Well, when you know it, that probably gives me more room down here anyway. All right. Now, 10x squared is perfect, but 10 is not perfect. That's the problem. 10 is not perfect. This 10 is not perfect. It's not a perfect square. On the other hand, look at this. I have a 9x squared first term, and I have a 64 last term. Question, are they perfect squares? What's the root? 3x. What's the root? 8. There you go. Put your minus sign there, bring the minus sign down, and square it, and set it equal to 0, and we're on our way. So this one is 3x minus 8 squared quantity is 0. What does that mean? 3x minus 8 quantity squared equals 0. This means that 3x minus 8 times 3x minus 8 equals 0. So then 3x minus 8 is 0, or 3x minus 8 is 0. I mean, just do it once. Don't do it twice. It's a double root, right? Solve only one of them. So 3x minus 0, add 8 to both sides. 3x equals 8, divide by 3. So x equals 8/3. There you go. One answer. It's x equals 8/3, but it's really x equals 8/3 2 times. It's what we call a double root, right? We have to have 2 answers because look, the problem is squared. This means 2 answers. Like with this one right here, example 2, we had 2 answers because it was squared. Okay? So whenever we have a square, we have to have 2 answers. So in this case, we have 2 answers, but it's just x equals 8/3 two times, twice. So it's like saying this, x equals 8/3 or x equals 8/3. But don't write it twice, just write it once. And there's your answer. Write it one time. Okay? All right. Okay. What else do we have for you in this section here? All right, 4.8. I think I have maybe 1 or 2 more examples of this. All right, here we go. Let's try this one now. All right. Next example. Example 1, example 2, example 3, example 4. Let's try 49 x squared equals 64. Solve for x. Step 1. It needs to be in standard form. That's always step 1. Standard form. Write it in standard form. So 64 needs to be brought to the other side. So 49 x squared minus 64 equals 0. This should look familiar. This is the difference that's between 2 squares. So this 49 here, this is 7x times 7x. And 64 is 8 times 8. So let me write the shell. The shell is going to be boom, 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 equals 0. 1 is plus and 1 is minus. That goes back to our lesson back in 4.7. All right. So I'm going to put this 7x with this 8. And then I'm going to put this 7x with this 8. Now solve each one. So 7x plus 8 equals 0, or 7x minus 8 is 0. Subtract 8 from both sides here. Now I'm going to get 7x equals negative 8. Divide by 7. They cancel. So x equals negative 8 over 7. That's one answer, one solution. Here, add 8 to both sides. 7x equals 8. Divide by 7. X equals 8 sevenths. And there you go. X equals negative 8 sevenths, or, not and, or x equals 8 sevenths. It's either the negative 8 sevenths or the positive 8 sevenths. Either one of them are going to give you 0, because when you put this in for x and you square it, right, it's going to be positive. And a positive minus the negative, and they're both going to have the same value of 64, equals 0. Okay. All right, all right. Okay. That's example 4. I think that's going to do it for these examples. All right, now let's take a look at something a little bit different. All right, now, what if we go another way? We've given you each equation and we found the answer. X equals negative 8 sevenths, or x equals 8 sevenths in this case, or x equals negative 8 sevenths in the first case. What if I give you the value of x and have you go back and give me the polynomial expression, or give me the polynomial expression or the equation. So now we want to go backwards and find the polynomial expression or the equation. We're going to start here and go back to here, instead of starting here and going in this direction. So now we're going to go in the opposite direction. Okay? So instead of starting here, here's what we did. We started up top and we worked our way down here. Now we're going to start at the bottom and work our way up to the top. We're going to go reverse now. Okay? Here we go. So, example 5. Let's write a polynomial given the roots. Y equals negative 5, y equals 0, y equals 1. Okay? There we go. So these are like answers, like x equals that or that. This is like saying y equals negative 5, or y equals 0, or y equals 1. So now you have what we call these roots. These are roots. All right, another word for roots, here are the synonyms of roots. You can call them roots, you can call them zeros, you can call them solutions, you can call them x-intercepts. These words are synonymous. They all mean the exact same thing. Exact same thing. It's according to your instructor or the textbook you're using that will determine whether you're going to call them roots or x-intercepts or zeros or solutions, but they all are synonymous. They mean the same thing. So here's what we have. We have our roots here. We have our 3 zeros here. And these are called zeros because that's what makes the polynomial equal to 0. That's why we put it in standard form, to equal 0. Okay, so these are the solutions that help the polynomial equal 0. These are the solutions that help the polynomial equal 0. This is the cause. Alright? So, what we have to do, we have to take each 0 and write it as a factor. Okay? Alright? So that's step 1. Write each 0 or root as a factor. Write each root as a factor. Okay? So if I want to write this y equals -5, this is the root. However, the factor is going to be y plus 5. That's the factor. You take this -5 and you move it on the other side of the equation by adding 5. By adding 5. In other words, if I have y equals -5, if I add 5 to both sides, I'm going to get y plus 5 equals 0. This y plus 5 is the factor. That's the point. The y plus 5 is the factor. So I take -5, add 5 to both sides, get y plus 5 is 0. So y plus 5 is the factor. So there we go. Y plus 5. Same thing right here. If I take y equals 0, move the 0 to the other side, I'm going to get y minus 0, or just simply put y. How about right here? Y equals 1. If y equals 1, if I subtract 1 from both sides, I'm going to get y minus 1 equals 0. So y minus 1 is the factor. So that's step 1. And all of these now equal 0. It all equals 0. Because this one gave me 0, this one gave me 0, and y equals 0, that's y minus 0 is also 0. So it's all equal to 0 now. So we're almost finished with this. So once you take each root and you write it as a factor, the last thing for you to do now is to multiply all of this together. Let's multiply it all together. Once we multiply it, that's going to do it for that one. All right, let's multiply it. Here we go. So watch this. So I'm going to have y times y plus 5 times y minus 1 equals 0. Ladies and gentlemen, this y right here, I'm going to bring it down. I'm going to bring the y down. And then I'm going to multiply y times y and get y squared. And then y times a minus 1 and get a minus y. And then 5 times y, which is going to be a positive 5y. And then 5 times a minus 1, which is minus 5. And that all equals 0, of course. Bring this y down again. Bring down y squared. Combine what's in the middle, because there's a 1 right here. Negative 1 plus 5 is positive 4. Minus 5 equals 0. We're almost done. Now take this y and distribute it on the inside. So now multiply y times y squared. That's going to give me y cubed. And then take y times 4y. That's going to give me plus 4y squared. And then y times minus 5 minus 5y equals 0. There's your answer. There's the polynomial. That's it. That's how you do it. I think that's going to do it for section 4.8. As you can see, it's much shorter. Much shorter than section 4.7. 4.7 was a lot, because that involved a lot of special factorization, so that was a lot, 4.7. But 4.8 is much shorter, okay? And so, again, if you have any questions, if you have any concerns, you can text me, you can email me, give me a ring, whatever you want to do, whatever best works for you to reach out to me, and I'll return your call, email, text, whatever. Probably tomorrow I'm going to do lesson 5.1, 5.2, because this is it for chapter 4. 4.7 and 4.8, that's it. And we're going to go now into chapter number 5. So the lessons will come more regularly now, since I'm set up, structured, and ready to go. Hope this helps. Please, if you have to stop it, pause, rewind, look at it again, slow it down, whatever you need to do. And if you're still not getting it, just reach out to me, and I will gladly help you. All right, thanks for listening. Thanks for coming to my little classroom theater. I'm at my home, and I had to kind of, do some adjusting here to make my home into like a little small classroom. It's just that I have no students in here. You're not here, but at least you're getting the lessons. And I hope it's beneficial. I hope it helps you. Till we meet again, take care. Thanks for listening. Thanks for coming. And now I'm going to try to go see if I can get a meal since I'm home. I don't know. We'll see. All right. Bye-bye. See you later.